Okay, so now we have this example in front of us, a small sample, female few entries and male few entries and their scores. So we want to check whether there is any difference between the two or not. When we opened, we go to data and we can see data analysis. And as I told you, if you click on data and you don't see it here, that means you need to go to File, Options, Add-ins, and then choose the Data Analysis toolpack and then get it installed. So I click on Data Analysis, and if I look at t-test, I have got three choices. So the first one is just about a situation where we are using the same group. For example, we had a student group, let's say all of them, and we were interested in checking whether a particular teaching method helps in improving scores or not. So we gave them a test, and the females had this score, and then the same females were given the same test after they were taught with that method, and we again checked them with a test. So we would have the same people having two different observations. So that is paired case. However, if we are testing different people, so females versus males, two entirely independent samples, so that is the case of two sample. Now here in this case, again we have two situations within those two sample. One is where we are assuming that the differences in score, that is variances, is same for this group as well as for this group. Now this is assumption, so either they are equal or unequal. So we need to check first which is the true situation. So our assumption is that they are equal, but whether that is the case or not, we need to get help from f-test, because f-test will tell us whether our assumption that the variances for female is same as for the variances for male, that assumption can be retained or not. So we go to f-test. So before we can do t-test, if you are using Excel, then we need to first go for f-test. So go to f-test and click OK. Now it will ask you where is the variable 1 range. So the cursor is blinking here. So I want that the label should also be chosen. So I need to click here, and then I go. Now see, I don't see the cursor blinking, so I need to go back and click here so that the cursor is blinking here. And now female, and go down and leave it. So it has chosen the range from female to 52. Now I want to give it the variable 2 range, so I need to come here. Now the cursor is blinking here, and now I need to go to male, go down, stop at 28, and it has chosen the variable 2 range. That is, label and the observations all have been chosen. You leave alpha as 0.05 by default, because that is usually the value that is used in all tests. Now by default it says new worksheet, so the result will go there, but it's better, it's such a small sample that we have result just next to it. So what we do, output range. Now if I make a little space for myself, so I drag it here, and while my cursor should be blinking inside this, so I bring it here and click here. Now cursor is blinking here. Now I go, let's say I want the result to come somewhere here, so I click here. That's fine. So result will start from here and go somewhere there. Okay, and now I'm happy with that to check my assumption, whether can I retain my assumption that the variances in this group is same as variances in this group. So okay, now just move it a little up. Okay, now what it's telling me, it's showing me mean is this and variances are these, but I'm interested in at the moment to look at this value, the p-value. If it was more than 0.05, then I would have retained my null hypothesis that the variances are equal. But if it is less than 0.05, then I have to reject my assumption, and I have to say that no, the variances are not equal. So of the t-test, I have to choose the one which says assuming unequal, because my equal assumption has not been proved valid as far as f-test result is concerned. So I go back, because actually I was doing it for helping me with choosing one of the two. So I choose assuming unequal variances. If this value was more than 0.05, I would have chosen equal. But since this value is 0.03, which is less than 0.05, therefore I choose unequal variances and go for, now again almost similar window. So I choose labels, then in the variables, while it's still blinking inside, I go to female, then blinking here, I go to here, and now output range. So I want, let's say I want the result to come here. So while it is still, cursor should be blinking here, otherwise it won't show you the result. So cursor blinking here, let's say I put it here and then click OK. So you can see the t-test result. What it's telling you, t-test 2 sample assuming unequal variances. So your assumption was of unequal. Now it shows you mean, variances, observations 6 and 5, and so we did not go for any hypothesized mean. Now df is just degree of freedom. At the moment, let us not discuss that for ease of understanding. Perhaps we can discuss it later on, but since it works it out itself, you don't need to really care about that. What we are interested in is to look at this value, the probability value, that is p-value of two-tailed test, 0.184. Now again, if this value is less than 0.05, then that means your assumption that there is no difference in the mean score of the two groups, that assumption will be rejected if it is less than 0.05. However, if it is more than 0.05, then you cannot reject the null hypothesis that there is no difference. So in this case, it's 0.18, which is more than 0.05. Therefore, you will conclude that though you can see that there is difference between the means of female and male, however, this difference is not such that you can assume for the population as well. For population purpose, this difference is insignificant, and you will retain your null hypothesis that there is no actual difference in the score of female versus male. So that's how you interpret the t-test, and that's how you run it as far as Excel software is concerned.